Welcome everyone. Today we are diving into the excited world of chat-based application and agentic AI systems which are at the forefront of modern AI development. Chat-based applications allows users to interact with AI models through conversational interface like chatbot or APIs, making them ideal for customer support, education, or task automation. The agentic approach takes this further by enabling AI to act autonomously using tools to reason, retrieve information, or perform tasks based on user input. These concepts are central to build intelligent, scalable systems, and they are in high demand across industries. In this room, we'll explore a foundational project from GitHub and Flask/Agent, which includes 4 Python files demonstrating chat and agentic implementation using LangChain, OpenAI, FastAPI, and FAISS. Then transition to a more advanced project, rag-agent-gpt-langchain, showcasing a retrieval augmented generation RAG for each file. I will explain its purpose, key imports, execution, and how you can benefit from and extend it. By the end, you understand how to build and enhance chat-based and agentic AI systems, provision you to leverage these trending technologies for career growth and innovation projects. Let's get started in PyCharm. Let's begin with agent.py, which demonstrates a basic LangChain agent capable of performing tasks like mathematical calculations. This file is the foundation of an agentic system, showcasing how AI can use tools to solve problems beyond simple chat responses. You can see the inputs here are from LangChain. Chat OpenAI sets up the GPT-4o-mini model for reasoning, initialize_agent and load_tools, create an agent with XML capabilities. An agent type defines the agentic behavior. We also use OS to manage the OpenAI key from the .env, that environment variable. And the purpose is to create an agent that can handle user prompts by combining LLM reasoning with tools, and in this case, a math tool for calculation. Execution, we initialize the LLM with chat OpenAI, load a math tools with load_tool, and set up a zero_attribute agent which reasons step by step without prior training. The run_agent function takes a user prompt like what is 5 plus 3 and returns the agent response, leveraging the math tool if needed. What we will learn, you will learn how to set up a LangChain agent, integrates tools for specific tasks, and configure an LLM with an API key securely. This is a stepping stone to build more complex agents. Benefit for developers, this provides a template for creating task-specific agents. For businesses, it's a starting point for automating processes like calculators and data lookups. For students, it's a practical introduction to agentic AI by adding more tools like web search, database queries available in LangChain ecosystem. Try integrating it with other LLM or deploying it in the production environment. Check with GitHub repo, GitHub and work skills/agents to fork and experiment. Let's look at the api.py, which imports our agent from agent.py as a web API using FastAPI. This file shows how to make an agent accessible over the internet, a critical skill for building scalable AI application. We import FastAPI for the web framework based model from Agentic for the data validation, run_agent from agent.py to process queries, and UVCon to run the server. The purpose is to create a simple post endpoint that accepts user prompts and returns the agent's responses. API.py. So let me execute. Run. So these are the warnings. We can ignore. The script is running on the 8000 port now. Let me clear this so that the logs comes up can be seen visible clearly. I have the sample. Let me copy this and then paste this sample, and this is a git bash. Pasting it here. Curl command, method is post. This is my URL, the localhost port is 8000/ask is my endpoint, the REST API endpoint, and the content type is application JSON and request body. The attribute is prompt, and the question is what is 5 plus 3. Let execute. Okay, I got the response. Fantastic. Let me see the logs. See the logs, how beautifully there is zero code being written from my end, but all these the logs, the information is tracing out to model and LangChain and then at OpenAI library. Viewers learn. You will learn how to integrate an AI agent with FastAPI server, handle HTTP requests, and validate inputs with Agentic. This is the key to building production-ready APIs. Benefit: developers gain skills in API development, enabling them to deploy AI services. Businesses can use the custom-facing chatbots or internal tools. It's also a great way to learn modern web development trends. Taking forward, enhance this by adding authentication, multi-endpoints, or integrating with front-end frameworks. You also can scale this by Docker or add error handling. Explore with the GitHub/and /agents. Contribute your ideas. Explore chat OpenAI API LangChain.py, which implements a simple chat API using Flask and LangChain or chat OpenAI. This file shows how to create a conversational interface without agentic capabilities, focusing on direct LLM interaction. We import Flask for the web framework request and JSON-API for handling HTTP requests, and LangChain, chat OpenAI, and human message for interacting with GPT-4o-mini, and OS model managing the API key. The purpose is to provide a basic chat endpoint that processes user messages and return LLM response. Let's execute chat OpenAI API LangChain.py file. This is without agentic approach. Right click to run. Okay. So this is started on the port 5000. Let me clear the logs. Okay. So I have a sample. Let me copy this and then so in this is the curl command, post method. The point is the chat running on the port 5000. Content type is application JSON, and the request body, the message. And the question is, what's the capital of France? So we got the response. The capital of the France is Paris. Execution immediately. What viewers learn? You learn how to build chat API on Flask and LangChain, process user inputs with an LLM, and handle HTTP responses. It's a great introduction to conversational AI. Benefits: developer can prototype chatbots quickly, business can develop simple Q&A systems, and students can learn Flask and LLM integration. It's aligned with the trend of conversational AI in apps. Taking forward, add features like conversational history, integrate with other LLMs, other enhancements, error handling. You could also deploy in the production server like Unicorn, and visit GitHub and work /agent to fork and experiment. Let's look at OpenAI chat completion.py, which implements the chat API using Flask and OpenAI native chat completion API. This is an alternative to LangChain, showing a direct approach to LLM interaction. We import Flask request, JSON-API for web framework, OpenAI for direct API access, and OS for the API key. The purpose is to create /chat endpoint that processes user messages using OpenAI chat completion API with GPT-4o-mini, providing a lightweight chat solution. Let's execute the script OpenAI chat completion.py and see how the script executes and what we get the result. Right click, run. Script started now on the port 5000. Let's execute. Let me copy the existing sample script from sample command to execute and see the result. Yeah, okay. Paste. Curl is command, method is a post, URL localhost, and 5000. The port, endpoint chat, content type application JSON, message is the request body, and the question asked is tell me a joke. Let's execute. Response: why did not the skeleton fight each other? They don't have the guts. Execution we did, and you saw the output. What viewers learn? You learn how to use OpenAI API directly, bypassing frameworks like LangChain, and build a chat API with Flask. This is ideal for understanding low-level LLM interactions. Benefit: developers gain flexibility in working with OpenAI APIs. Businesses can build lightweight chat systems, and students learn an alternative to LangChain. It's relevant to trend in direct API interactions. Take it forward. Enhance it with messages tree. Try other OpenAI models or add input validations. You could also integrate it with front-end or deploy in productions. Check out, play around, and work skills /agents to contribute. Till now, we were looking into the chart-based approach. And now, we will start looking into the agentic-based approach. RAG agent with GPT and LangChain. The agentic demo. Let's begin. Why this matters at all? RAG is a cutting-edge technique for building intelligent systems that leverage external data, making it perfect for applications like knowledge management or customer support. You will learn how to integrate a vector store using embeddings and deploy a production-ready API with Docker. Benefits and growth. Developers can build scalable AI systems, businesses can deploy advanced Q&A tools, and students can master trending RAG techniques. You can extend this by adding more tools, expanding the knowledge base, and integrating other LLMs. Overview. Project: Retrieval Augmented Generation, the RAG agent. Tech stack: LangChain, OpenAI, GPT-4o-mini, FAISS, FastAPI. Repository: github.com/env-skills/rag-agent-gpt-langchain. Access: public open source. Use case: query answering system that combines document retrieval with LLM reasoning. Example: Retrieval information from a text corpus. What is LangChain? And generates precise answers. Ideal for Q&A bots, knowledge management, or customer support tools. Benefits: scalable, easily extend the knowledge base or add new tools. Accessible, simple API interface via FastAPI. Deployable, Docker support for local or cloud deployment. Open source, freely available to use, modify, and contribute to. What you will learn: how to build a RAG system with LangChain and FAISS. Integrating OpenAI GPT-4o-mini for intelligent query processing. Setting up a FastAPI server for API-based interaction. Configuring and deploying with Docker. Viewers benefits: developers gain hands-on experience with LangChain and RAG. Businesses prototype intelligent and Q&A systems for internal or customer use. Students learn modern AI and web development techniques. Open source enthusiasts contribute to a real-world project. How to enhance: add more tools, example web search, database queries. Expand the knowledge base with diverse data sources. Swap biases with other vector stores, example PyCon, Waviate. Integrate alternative LLMs, example open source models like Hugging Face. Demo preview: walkthrough of project structure in PyCharm. Code explanations such as rag retrieval, agent logic, FastAPI endpoint. Live demo: querying the API with sample questions. Tips for running and extending the project. Getting started: clone the repo. Git clone github.com/rag-agent-gpt-langchain. Follow the README for setup instructions. Contribute your ideas, issues, pull request on GitHub. Let's start the agentic demo. The very first, you have to clone the repository from GitHub and workskills, the rag-agent-gpt-langchain, and once you do that, we will see the files as this. So we have a requirement.txt, readme.md, main.py, license, docker file, environment file, data folder, agent folder. Well, in the requirement.txt, we have the libraries. These are the libraries which should be installed to execute the script. And the readme.md file gives you the clear information about this project, this application, what it does, what all the files are there, how it is getting executed, what each library is doing. It's been clearly defined in this. Okay. And then we have the main.py file which actually execute this script, this application on port 8000. It is not like 8000 is mandatory. You can change it to any other port which you feel convenient, as most of the people use 8080 and most of the people use 8000, something like that. Okay. And as once this script is running, you can see this script runs with an endpoint called /query. This endpoint try to capture the user query, and this user query will be consumed by run_agent and gives the response. This is the final response the users will be going to see. Run_agent, this method is getting loaded from agents.agent. This is coming from the agent folder, agent.py. So we'll talk about this more in a few seconds. Agents folder has two files, agent.py, rag.py. Let's explore rag.py. Rag.py, also known as Retrieval Augmented Generation, which is the functionality using LangChain and FAISS. Load_documents function begins by reading our knowledge base from /data/knowledge.txt using text loader. It then splits the text into smaller chunks with the character text splitter to ensure efficient processing using a chunk size of 300 characters with a 50 characters overlap. These chunks are converted into embeddings with OpenAI embedding and stored in a FAISS vector store for fast similarity searches. The retrieve function performs a similarity search on this vector store for a given user query, returning the most relevant text segments. Finally, we wrap this retrieval logic in LangChain tool named rag-retriever, which our agent uses to fetch relevant information when answering queries. Now let's move to agent.py using LangChain, initializing the rag agent with chart OpenAI with the configuration GPT-4o-mini model. We load the OpenAI key from .env file using python-env library for secure configuration, loading the initialize_agent with chart OpenAI initialized object as LLM, and the agent is set up with a single tool, our rag retriever from rag.py, and also uses the zero-shot React description agent type, which allows it to reason and decide which to use the retrieval tool. The run_agent function takes a user query and returns the agent's response. The knowledgeable.txt file is the data folder, is our sample corpus. Right now it contains a few lines about LangChain, but you can add any text data you want to retrieve from. The Docker file sets up a Python 3.10 environment, installs dependencies, and run the FastAPI with UVCon. This makes deployment super easy whether you are running locally or in production. Okay, let's execute the script now. Double click on the main.py. I can do right click, run main, or else from the terminal I can type main.py and it should execute python space main.py. We have to make sure the environment is activated. So let's execute the script, the application. I have right clicked and run. Yeah, so application got started and the port is on 8000. Let's open the browser now. Okay, so let me enter the port, IP address, the localhost colons 8000. So if you know, currently this application I have initiated using FastAPI. So FastAPI has a browser Swagger documentation, the API documentation. Using that also we can test our REST API. So the URL for that is docs docs and then enter. Okay, so this is what the API /query. I have clicked on this. Let's try it out. Let me enter. What is LangChain? Execute. We got the output. LangChain is a framework for developing applications powered by language models. It enables easy integration of external data source and APIs. It allows agents to use tools to interact with the environment and solve user problems. Okay, what is the logs? We got the output beautifully, and see the logs has also been printed neatly. This is all the library which is actually doing LangChain library with the combination of chart OpenAI. This is the question which we asked and the observation. See how it is like thought. I now have more details understanding of LangChain and its functionality. Final answer, and then it's articulated the answer and the response is okay. Well, this is how our script, the development, the RAG application, a small implementation which you can explore. Now let me also try to show you this script running via Docker. So I should be going to the location of this folder, this application, right click, open in Explorer. CMD. So got the command prompt. Now let me type docker build d rag agent gpt-langchain space.t. Oof, I got the error. What I missed? Oh, I'm not in the exact path. Let me go to the project path, project folder, rag-agent tab space. I'm in. Okay, I have the files. I'm in the folder. As I already entered the command up arrow, I should be seeing my existing command. Enter. Yeah. So Docker got executed. Yeah, one thing we have to make sure Docker. This is the Windows, right? So what I did is to make sure Docker desktop I have started first, and then the Docker command I could be able to run, and we can see Docker images. Okay, so that is how it is. Now let me execute this one. The Docker is built, the image is got created. This is the image ID. But before I start, let me stop which is already running. Yeah, otherwise the port conflict will happen. Okay, so let me type the command. So this is how it is. Docker run -p port 8000. So this is for the external port and this is for the internal port. -env file .env. I want the environment variables to be get loaded, and the application name, the Docker name, what I given is rag-agent-gpt-langchain. Yep, it should run now. Okay, I see it's started on port 8000. Let me open the browser. It's already there, so which I tested before, but even though, let me open the other browser just to cross check, make sure. Enter. We should see. Try it out. What is LangChain? Execute. Let's see what is happening. Okay, we got the response and we got the logs, and see how neatly the logs are presented. This is really beautiful. This is a really agentic, something the agent is doing the crazy work. This set of code, if really we need to implement, would have been taken a lot of time, probably the days, but this agentic libraries which really helped us to fine-tune our implementation to make it work efficiently, productively, very fast. Let me also show you the GitHub location repository. So I request you all try to play around with the env skills /rag-agent-gpt-langchain. Check out this repository and explore this code base. You can commit and you can comment, and you can use it for your own experiment and exploration using this code base. Taking it forward, extend functionality, add tools, web search, SQL queries, integrate other LLM Hugging Face models, or enhance APIs with authentication and front-end. Scale development use Docker as in rag-agent-gpt-langchain or cloud platform like AWS or Heroku for production. Contribute to the repo, submit pull requests or open issues with ideas for new features. Experiment. Try swapping FAISS for PyCon in rag-agent-gpt-langchain or adding conversational history in the chart API. The viewers benefit and relevant to trends. Developer gain hands-on experience with LangChain, FastAPI, plus RAG, which are in demand for AI and web development roles. Businesses prototype chatbot, Q&A system, or knowledge base that can be deployed internally or for customers. Students learn modern AI framework and APIs, building a prototype aligned with industry trends like Agentic AI and RAG trends. These projects align with the rise of conversational AI, agentic systems, and retrieval augmented models, which are transforming industries like tech, education, and customer services. Growth. Mastering these skills positions viewers for roles in AI development, enhance their ability to contribute to open source projects, and open opportunities to innovate in AI-driven application. And please let me know if you have any suggestions or else any comments, or you are expecting anything different examples which you're really looking, so that I can create a next training video for that, show you all. Well, thank you so much for watching this video. See you soon. Bye bye.